Let's look at an example here. This is all, remember, the chemistry is about relationships between different molecules, different substances, and it's the same thing with real life. Now, there was a student of mine, a young lady, and she liked a young man. But the thing is, does the young lady at this school, now she goes to school A, and the young man goes to school B, does she talk directly to the man? No. The young man, no, she does not. Of course not. So what does she do? She talks to a trusted teacher at school A. Now, does the teacher talk to the young man directly? No. Of course not. He talks to another teacher at school B. And then he talks to the young man. So these are the moles. The moles are the only thing that can talk to each other. You don't go from one thing to the next directly. You have to go through the mole. Okay? So when a girl talks to a boy, they don't. I mean, does that ever happen? A girl directly talks to a boy? No, of course not. So here we have Brianna and Blake. She said, Mr. Teacher, I really like Blake at the next school. Can you arrange a meeting at the malt shop? And I'll say, sure, Brianna. I will talk to a teacher at that school. And I talk to the teacher, hey, teacher, talk to young Blake and tell him about Brianna, excuse me. You must go through the mole. It just brings me, this is a side point. A lot of people ask me, hey, Mr. Barron, what do you look like without a beard? So I just thought I'd show it to you. And there I am without a beard. I know, I don't mean to brag, but I do look good. I do look good. Thank you. So back to this. What do we do nowadays? The old days, they talk to a teacher. So Brianna, what would she do? And then Blake, she wants to talk to Blake. What's the mole now? The mole now is Facebook. So this is Brianna's mole. And that she doesn't talk directly to Blake. She talks to Blake's mole. Well, she doesn't go up directly to Blake and say, hey, I like you. She goes to the Facebook. The Facebook goes to his Facebook and to him. That's the mole. You go through the mole. So keep that in mind and you'll be fine. Okay, in chemical terms, we go from mass A to moles. We use the periodic table. And from there we go to mole B. And that's with the balanced equation, which we did all just at the beginning here. And from there we go to mass B. So if we have mass of A and we want to know mass of B, we have to go through the moles using the balanced equation. When you decide where to start, that's based on the units you're given. So you might be starting with grams and then stop based on the units you're given. You might start with grams and end with moles. You might start with moles and end with grams. You might start with liters, you might start with particles and end with grams. Or liters or particles. But either way, you have to go through the mole. Now let's try an example here. We have this problem. How many moles of C2H2 are needed to produce 8.95 grams of H2O? So we have to start with what we're given, grams of H2O. We have grams of H2O, and we want to know moles of C2H2. How do we go from this to this? Well, all we can say is we have a problem. We go to the mole, our friend. So we go to moles of H2O. That talks to the mole of C2H2, and that's exactly what we're trying to find. And that's it. So let's go to the mole. How many moles? We start with 8.95 grams of H2O. And we got to go to the mole. of H2O. Now we've done this before. How many moles of H2O? In 1 mole of H2O, of 18.02 grams of H2O. All right, so this is from the periodic table. Now we have to do the mole ratio from the equation. This is from the equation. We always do the mole ratio from the equation. What do we want on top? We want moles of C2H2 on top. 2 mole C2H2, because that's what we want to end up with, over 2 mole of water. And of course, this just becomes 1, so you don't even have to put it in, but let's just do that. The moles of water will cancel out. The grams of H2O will cancel out. So we'll just multiply across, and we get 0.497 mole of C2H2, and that's about half a mole. Let's try another one. If we have 2.47 moles of C2H2, how many grams of carbon dioxide are formed? All right, so this is a little different what we're starting with. We're starting with moles of C2H2. Now we want to get grams of CO2, and the only way we can figure that out is if we go to the mole of CO2. Then we can get grams of CO2. So let's start with this. Mole of C2H2. All right, so we start with the moles of C2H2. That's 2.47 mole of C2H2 over 1. And so we go to the mole ratio here to get to moles of CO2. Mole ratio, 2 mole from the equation. This is the mole ratio from the equation. C2H2 on the bottom, so it cancels out. And that is to 4 mole of CO2. We want to go from moles of CO2 to grams of CO2, and we have to go from the periodic table with that. 1 mole of CO2, we put that on the bottom, so it cancels out with the 4 moles over here. That's 44.01 grams of CO2. And we get, with sig figs, 217 grams of carbon dioxide. So here we have this problem. 10.1 grams of iron are added to a solution of copper 2 sulfate. How much solid copper would form? Now we should be able to write this equation out. So this would be iron plus the copper 2 sulfate. That goes together because copper 2 is plus 2. Sulfate has a charge of 2 minus. And we are doing a single replacement, so we get this, but now we're going to have to balance it, and we balance here. What do we have to do? We have to go from grams of iron, and it asks how much solid copper would form. That's grams of copper. How much? So we want to go from grams of iron to grams of copper. That means, what do we have to do? We have to go to the mole. They don't talk directly to each other. They have to go to the mole of iron. The mole of iron will talk to the mole of copper. And the mole of copper will talk to the grams of copper. So the first thing we do here, and the second thing, and then we have the third thing. Here, the second one, going from mole to mole, the mole ratio is always from the equation, the balanced equation. So we have our start with 10.1 grams of copper, and we have the conversion factor. We're figuring out moles, so that's the first thing. And the second thing, this is from the equation. 3 moles of copper is to every 2 moles of iron. That's from the equation. And the third thing, we go from moles of copper to grams of copper. And 1 mole of copper, this is from the periodic table, is 63.55 grams of copper. And the fun stuff, we cancel out the moles of iron. We're left with grams of copper. And we have grams of copper, 17.2 with sig figs. Make silicon for computer chips to use this reaction. How many grams of magnesium are needed to make 9.3 grams of silicon? All right, so what do we want to know? We want to know the grams of magnesium from grams of silicon. We have grams of silicon, and we want grams of magnesium. So what do we have to go to? The silicon can only talk to the mole. The grams can only talk to the mole of silicon. Those moles talk to each other. They're like translators. And then from here, so the first thing we do, that's with the periodic table. The second thing is the mole ratio from the equation, and then the third is the periodic table again. So these are really all very similar to what we did in chapter 10. It's just that we need to, we're just taking one more step really. So grams, we start with 9.3 grams of silicon. So we have 1 mole of silicon is 28.09 grams of silicon. That's the first thing we do, going from grams to moles. The second thing we do, this is from the equation. We have 1 mole of silicon to 2 moles of magnesium. Then the third thing we do, we go from moles magnesium to grams of magnesium. Now we've done this a million times, hopefully by now. So 1 mole of magnesium, 24.31 grams of magnesium, and we cancel all this out. Grams, grams, moles, 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 and we get 23 grams of magnesium with 2 sig figs with the 2 sig figs here. Now using the same equation, we ask this question now. If we have 3.7 grams of silicon tetrachloride, how many grams of silicon would be produced? We go from grams of silicon tetrachloride. We have to go to the mole. Mole of silicon tetrachloride. We go to the mole of silicon to just silicon. The first thing, second, we get from the equation. Going from mole of one thing to mole of that next is always from the equation. Going from grams to moles and moles to grams is from the periodic table. We start with 3.74 grams over 1. This is the first thing. This is from the periodic table. 1 mole. The second part, going from mole to mole, we always do the equation or get from the equation. So we have 1 mole of silicon tetrachloride is to 1 mole of silicon, so that's not going to change anything. And then the part 3, and then we have this 28.09 grams of silicon per 1 mole of silicon. That's what we get from the periodic table. We multiply it together, and we get 0.619 grams of silicon from 3.74 grams of silicon tetrachloride. How do you get good at doing these? Well, practice. You keep doing examples and examples until it's second nature. You don't have to think about it anymore.